Hello 20-1 students. So today we are looking at the second part of our lesson 9.3. So we're still looking at quadratic inequalities in two variables, but today we'll be just applying that to a couple of word problems. And if you can believe it, this is our very last lesson of the course, so way to go in making it this far. Alright, so we have a word problem here that says a satellite dish is 60 centimeters in diameter and 20 centimeters deep. The dish has a parabolic cross section. So basically that just means if you look at it edge on, like from the side, then it would have the shape of a parabola, right? Which I know they don't really do that anymore, but you know, they used to see a lot of people with the satellite dishes on their roof. So then you would probably be familiar with that shape. It's basically just kind of like a bowl shape. So it's telling us to locate the vertex of the parabolic cross-section at the origin. So our vertex, right, the point here, and they want us to start by placing that on the origin of our graph, so at 0, 0, and then sketch the parabola that represents the dish. So basically all we want to do is, if we have a 60 centimeter diameter, remember that's going to be the total distance across, so our axis of symmetry here, which is our vertex, should have 30 units on either side to represent the diameter. So basically each half represents the radius. So we could go like 5, 10, 15, 20, 25, 30, so it'd be negative 30. And then the same distance will be there for positive 30. The dish is 20 centimeters deep, so this kind of part here would be 20 centimeters. So let's go 5, 10, 15, 20. So there's our kind of 20 mark. And so we just want to find the cross point for those, or the coordinates for each end point of the dish. Okay, and then I will just sketch in a parabola. Okay, I didn't want to make you guys sit through the painful process of me trying to draw that because it's always hard. Okay, so we've done what they asked. We located the vertex, and then we sketched the parabola that represents the dish. Now they want us to determine an inequality. So basically that's writing the formula of the graph, but with, instead of an equal sign, we need to figure out, whether it be greater than, less than, that kind of thing. So determine an inequality that shows the region from which the dish can receive the signal. So we just want to start out by writing our formula for the graph, and remember that, like we talked about in the last lesson, that would mean we want to start out by writing it in the vertex form. So remember that's y is equal to ax minus h squared plus k. And our h and k values are the coordinates of our vertex. So in this case, we located that at 0, 0, which is nice because it makes this really straightforward. So we're going to say x minus h, x minus 0 is just x, so squared. And then plus k plus 0 is still 0. So here's our formula for the graph, y equals ax squared. Now remember, to have the proper complete formula, we also need to have a value that we can put in for a. The only variables that should remain when we have our full inequality are the y and the x. So in order to solve for a, we just need to pick any point on the graph, like along the parabola, to substitute in. So for example, we could just choose the end point there because it's nice and easy. We already have the coordinates. So that would be, let's see, x is 30 and y is 20. Okay, I'd say for a graph like this, make sure that you choose a point that you know for sure, because we're drawing it, so it's not going to be perfect. So try not to use any kind of points in between where you're just guessing what the values would be. So 30, 20, so that means our y value is 20, which is equal to a times by x, which was the 30 squared. So then we have 20 is equal to 30 squared is 900a. And we want to divide away the 900, so we isolate a. So that's going to leave us with A being equal to 20 divided by 900. So basically we just need to kind of reduce that into lowest terms. So if you do half of that, you'd end up with 10 out of 450. And of course we can divide both of those by 10, so we end up with 1 out of 45, which can't be reduced anymore. So A is equal to 1 out of 45. So now we would say, like, our formal kind of final equation for the graph is y is equal to 1/45 x squared. So that's our equation, but of course we want to write it as an inequality. In order to make it an inequality, we need to determine what sign would go here. Now you can, of course, you're going to want to use a test point to verify. Hopefully you kind of understand, though, that if this is the shape of the dish, because it's asking an inequality that shows the region from which the dish can receive a signal. So remember, the reason why we have this parabolic shape is because it can kind of gather signals in towards itself. And so all the signals are going to come from here. So basically what I would expect is that the region above the graph is going to be the parts where it can receive a signal from. So I'm going to expect that it's going to be greater than, and of course right up until the signals can be gathered by the dish right to the actual physical dish. So it's going to be greater than or equal to, right? There's no like boundary there where it can't hit the dish. So y is greater than or equal to 1/45 x squared. Okay, so we can kind of think it through like that, a little bit of logic. Where are the signals coming from? Is it going to be able to actually touch the dish, which is actually the whole point of it, so yes. So those are things that you would consider when you decide what inequality to write. Now, of course, we want to write a test point to confirm that this inequality would be true for this region. So you can pick kind of any point from in here to substitute in for your x and y values to verify. So for example, I would go like 5, 10, 5, 10 maybe. We could do 10 and 10. That'd be a nice even point there. So then I would say, okay, y is 10 greater than or equal to 1/45 times by x was also 10. 10 squared. I'm already doing the math, which is 100, but I'll keep it written out properly. 10 squared. So yeah, basically 10 is greater than or equal to 100 out of 45, which is, should just 100 divided by 45, I believe it's 2.2. So 10 is greater than or equal to 2.2 repeating if you do that division there. And this is a true statement. So that means that we've set up our inequality correctly. And it also means that in terms of shading, we would shade the area above the parabola. So essentially, this would be true. And the other thing we can also confirm is that we drew our line properly. So because it's greater than or equal to, it's good that we used a solid line to draw our parabola there. So we've kind of confirmed that everything is good. Now, it doesn't actually ask you for this in this one, but I would like you guys to be able to, because in the tests you will have the requirement to write a proper domain for a word problem. The important thing with writing a domain is that you always have to remember to account for the reality of the situation. So if we were writing our domain for this one, we would say, so we put x and then our line. So for this particular one, we're just going to be going to the edge of the dish, right? So that the dish can only collect as far out as it kind of goes. So we would say that x has to be greater than -30 and less than 30. So -30, x is greater than or equal to, and x is less than or equal to +30. So there's our domain for that question. Okay. All right, so if you guys want to give one of these a try, there's a similar kind of a question here. Same thing, kind of dealing with the same kind of a shape here. So you can pause the video, give that one a try, and as I kind of have the answer down there, the full worked solution is in the textbook, so you can always check that to confirm that you get your answer right. And then when you're finished with that, we'll move on to example 2. So in this one, we have Frank and Jenna are sports climbers. They use a rope that is longer and supports less mass than a manila rope. I'm not sure why that matters. The rope can safely support a mass m in pounds modeled by the inequality m is less than or equal to 1240 d minus 2 squared. So that's kind of nice. They actually gave us the inequality. We don't have to figure that out. Where d is the diameter of the rope in inches. Graph the inequality to examine how the mass that the rope supports is related to the diameter of the rope. Okay. So with this one, I would say like you're kind of given this inequality already. So I would go ahead and put it into my graphing calculator. So I'd go into y equals, and I'm going to enter in 1240 x minus 2 squared. And then if I go to my graph, I gave you guys some window settings that are convenient for this one. I would recommend that you guys, of course, I think I've mentioned this before, make sure that you're comfortable with adjusting your window settings as well. So just kind of be used to playing around a little bit with that to figure it out. But this is a nice clear vision for us of what's going on there. And then if we want, we can just like really quickly sketch it out as well, because we want to be able to solve for our inequality by figuring out where to shade and things like that. So let's go second function trace. Let's find our minimum here, or our vertex, left bound, right bound. And it's going to be at... Now, sometimes the calculator does this, but we can also just look at this because it's basically written in vertex form. So we have essentially like x minus 2. So we know that's going to be, the x value is positive 2. And then we don't have any number added on. So that means the y value is 0. So that means our vertex is at x being equal to 2, y being equal to 0. Okay, so you could have found that information out either way. The main tricky thing is like now, if we have that, we need to be able to solve for other parts if we want to actually sketch it out. So the other part I looked at was, let's see, trace, or it's never going to give us a nice even number. Maybe not. Let's try doing second function value. Let's try for 0.5. Okay, so when x is 0.5, y is 2790, 2800. So basically that would mean here we're at 2. Oh, you know what? Let's do when x is 1 first. That makes more sense. Y is 1240. So we see that our numbers here are really big, but like I mentioned, when you're setting up your windows, if you set up the Y scale to be 500, so we can do the same on this graph here. So be like 500, 1000, here would be 1500, so 1240 would be about halfway in between, and we're at x equals 1. So our scale for our x was 1. So there's our 1 coordinate, and then we can just use our mirror image to know that we would have another point there. And then we could still go in and do that trace value. We could put one at 0.5. So if we go to a half here, we're at 2790. So that'll be 500, 1000, 15 to 25. And that's kind of like 2750 is about halfway. So I'm going to put that right there. And then again, I'm going to work with my axis of symmetry to figure out that I should have the... Oh, wait a minute. Got to count that out properly there. 1.5, not a half. Okay, so there's my other point there. Okay, so now I have kind of my graph figured out. The next thing I want to determine here basically is we're looking for basically figuring out how mass is related to diameter. So we want to figure out where to shade, and because we already have the inequality, we can do that using this. So we're told that m is, which is our y value, is less than or equal to 1240. So less than or equal to means that it's good we use the solid line there. And then because it's less than, that means that the true solutions for the relationship between mass and diameter are going to be found outside of the parabola. So we're going to shade that region. Okay, so that's our shaded region. Then we want to kind of look and figure out how we could test a point inside of this true area to figure out this relationship. So for example, my favorite, 0, 0. So that would mean m was 0 less than or equal to 1240 times by 0 minus 2 squared. Which gives us 0 being less than or equal to 1240 times by 4. Right, negative 2 squared will give us 4. And so that gives us 0 being less than or equal to 4960. Okay. So basically, we know that this inequality is true. 0 is less than this value. So if we think about the point we substituted in there, 0, 0, 0 is our diameter, and the second 0 is our mass, our y value. And so basically what this is telling us, when this is true, it means that if you had a rope of diameter 0, it would support a mass of 0, which makes sense, right? Of course, that basically means you have no rope, so it's not going to support any mass. So that makes sense. And then for any other point that you could pick here, you would be able to find like a diameter and a mass that would work together. So if you want to actually be able to make a statement about how those things are related, you might want to find a point that would actually kind of work. Like, so for example, one of the points we plotted there was when x was 1, y was equal to 1240. And so again, remember this stands for a diameter and this stands for our mass. So if we had to interpret this verbally, basically all we would say is that if we just look at our units, diameter is in inches. So we would say a 1-inch rope supports, and then our units for mass were pounds, so supports 1240 or 1,240 pounds. Okay, and then you could look at any other point in the graph and figure that out. Now, of course, again, if we were to state a domain for this graph, this time let's actually do domain and range for this one. So for the domain, we want to think about what would make sense. Domain is our x values, which is our diameter. So is it possible to have a negative diameter value? Obviously not. And so basically we would say that for our domain, x has to be just greater than 0, right? Actually, I should change that because the variable we were using was little d. So for our domain, we would just say d has to be greater than or equal to 0. We could do 0 because you could have a 0, like no rope, and then we know that that supports 0 mass. But other than that, we can also say that domain equals all real numbers. So as long as it's greater than 0, we can figure out the mass that would be supported for any diameter. In terms of our range, kind of the same thought process, right? So we're looking at mass, and again, we can't have negative mass, so we would say mass has to be greater than or equal to 0, but other than that restriction, mass can be equal to all real numbers. Okay. So that's everything. Just make sure with these problems, I know I didn't write it out all verbally, but just make sure that you can kind of explain and relate any of your calculations to what it's actually saying about the real life situation. There will definitely be questions like that on the test. So if you want to see kind of everything clearly written out, just go ahead and have a look at those filled in notes. You guys have a chance to try one that's similar to the one we just did here. So give that one a try. Make sure you check your answers And then when you're finished with that, go ahead and work on your assignments from the textbook. And then, of course, we're at the end of chapter 9, so you can go ahead and work on your chapter review and do the practice test from the textbook as well to prep yourself for your very last chapter test. So good luck with everything, and I guess that's it for the course. So maybe we'll see you in 30-1. Bye.